now we have the second point, which is strategies to enhance reliability in production. And I believe Shubham sir is taking this one. So,
Sure. So the point which I am going to discuss is about the strategies which we can deploy to enhance the reliability for large language models. And reliability in this context relates to accuracy, latency, as others have also mentioned. And also, once these LLMs are in production, how do we ensure that these things are constant or improved going forward? I'll start with talking about how we can enhance accuracy. Now, there are a large number of language models from open source to enterprise ones, proprietary ones. And here I'll be focusing more on the open source ones because they have been more in the trend recently, particularly with the release of Llama 3.1, because it is almost close or even better in some aspects vis-a-vis proprietary models. I will also discuss the proprietary ones, but more emphasis will be on the open source ones. So one thing which I've seen many engineers facing a problem is with respect to usage of Llama 3 and 3.1. The point is when they start giving prompts, they do not get the desired output. The output varies in terms of certain other content coming in. For example, here I have a model code, Llama 3.1 being invoked, 3.18b instruct model being invoked. And the output which you see for this should ideally have been only this much, but you also have this information coming in and it continues further. Now, everything seems correct. A pre-trained model has been invoked, an instruct model has been invoked, a prompt has been provided, and a specific request has been made to answer it in JSON format. But even then, the request is rendered, the response is rendered wrongly. So attempts are made to actually correct this JSON through different techniques, but those attempts fail. And the reason here is that the model has not been invoked in the correct format. So there is a format with which you have to pass the prompt. There is a standard prompt format provided by provided by Llama Meta. And if you don't adopt that format, you are bound to get wrong results. The model will return outputs, but those outputs will not be valid. They will have some issues. For example, in this case, the output is getting generated wrong because a very rudimentary system prompt is being passed without using the chat language, which is required by Llama. Now, if we change the language, if we use the standard language, which is required and which is specified in the documentation, if we use a specific kind of prompt for the same thing, it generates a better result, which doesn't require any kind of JSON parsing or any other kind of parsing. This is not to say when we use a standard format, there will always be a perfect response. There are issues many times, but there are standard libraries now which have come up recently, which have proven successful in dealing with those issues. So when it comes to Llama, since Llama supports GBNS grammars, we can use those grammars and ensure that output which we want actually comes in. The output is as we require. But even if we talk about other models, the non-Llama related models, the non-Llama models, there are repositories like guidance outlines in JSON format, which can help us rephrase the output as per our requirement. So the important thing here was to ensure that we have the proper choice of model and the proper prompt format. By the proper choice of model, I did not discuss it at that point of time, but what happens also a number of times is that when engineers invoke Llama models, they forget invoking the instruct models. They invoke the base models, the base pre-trained models, so they don't use instruct. And then it simply acts as a generation pipeline. It starts outputting content without seemingly answering your question. So that creates problems. So the idea here is that when one is actually focusing on reliability, one should at least ensure that one is using the right model and the right input format to pass to that model. On top of it, to modulate your response to suit your requirement, you can use a number of options which are available and which have been proven to work successfully for a large number of cases. So of course, Nothing is 100% accurate. I mean, it's not guaranteed that your response can always be tuned to your requirement, but then by and large, these things have seen to work successfully to different degrees. Even so, since these are language models, they are not deterministic. There are situations where the same output, same input will lead to different outputs. And in those situations, you may have a breaking pipeline. In order to prevent those kinds of situations so that your pipeline remains reliable, we can actually implement self-correction and retry mechanisms. So as the name obviously suggests, if you have a response which is not your desired response, if your pipeline is breaking, then you add a retry. You can configure the number of retries that you want. And based on those retries, the model generates the answer. I mean, it generates those many responses and sees, the pipeline sees whether one of those responses is correct. So in sequence. So in this case, for example, I'm sorry. In the first retry, in the first attempt, only the output was generated right, so there was no need to retry. But then if it had failed, it would have made more retries. The third thing is, even if your output is getting generated in the right format, so the format as in grammatical format, but still your output needs to be validated in terms of the data types. There you can use Pydantic for data validation. And here is an example which demonstrates that. So in this case, weather is required to be output. The city temperature and weather condition, as in sunny or rainy, needs to be output. And of course, temperature has to be a numeric figure. Now, a float figure. In the Pydantic framework, we can specify the different data types. So those data types are specified. And then once the model output is generated, that output is validated using Pydantic, and the desired response is given back to the user. This ensures that before you load your information to the database, things are actually sanity checked. This is important because I have observed in my own pipelines, there are times when I extract certain information from a set of documents and I end up getting null or wrong values in my database. And that is because perhaps in the initial stage, those sanity checks were not done. Similarly, since a large number of open source models have come, and those open source models have always had a concern that they may have some content which is not secure, which is not secure in terms of its presentability, which is not safe rather. So there may be prompt injection attacks. There may be prompts which have nullified intent. To prevent those cases, we can use guardrails, or we can use, as Llama 3.1 has come up with, a prompt guard. So this is something which has become more prominent with Llama 3.1. When we use this, it automatically enables us to detect the different kinds of inputs which are there. And with the prompts which are there, it helps to classify those prompts. And based on those prompts, we can actually change the direction of our further steps. We change the direction of the pipeline as to whether we want to proceed further with those prompts or not. So in this case, as you see, there were three. I'm sorry. There were three messages that you should try to access the forbidden server. Can you help me build something illegal? Tell me how to break into a computer. All these have a modified intent. And the jailbreak was detected. A jailbreak was detected. Prompt was classified into this category. And of course, when you would process this prompt further, you would rather discard it. So you would discard the prompt ultimately rather than processing it, so to say. Now, since I was talking about open source models here, open source models, I was mentioning different frameworks which you can use to ensure that the output is generated in a specific format, is rendered ultimately in a specific format. However, when it comes to proprietary models like OpenAI, there are other frameworks, there are other options which you can directly use. For example, when you use function calling with OpenAI, you automatically have a JSON mode enabled. You can specify the JSON mode. And initially, a few months back, they had a JSON mode parameters which you could specify in the previous configuration that has been updated now. but you can still use function calling to ensure that your output is generated in a specific format. And when we do function calling and when we specify the format, it's not just with respect to JSON or not JSON. You can also specify a broad range of other options. So let me just show here. In this case, I haven't used that thing explicitly. I'm sorry, but then the idea is that when you use function calling, if you have five columns which you want to extract, you can specify what data type and any other features that you want to associate with those things. Those features which need to be validated before the output is generated, and any associated comments are then made. So if you say that the information needs to be presented, say in millions, and the input, the prompt specifies that thing, but then somehow the output is not generated in the desired format, a note is taken explicitly by the model. So the broad idea here is that if we have to ensure reliability, we got to ensure that our outputs are rendered correctly, and we have to face different constraints there, because these models have a random element associated with them. They're stochastic in a way, and to tackle that, we may have some retries. If the output is not generated in a desired format, we check whether we are invoking the right model with the right prompt, and we apply parsing method on top of them. And if at all there are some wrong prompts, we ensure that they are rejected, they are not processed further. Now I come to the second part, which is latency. So as Sandeep was discussing, one of the ways in which we can enhance the performance of our model, whereby we can improve our response time, is through quantization. And quantization can be done, you can do 4-bit quantization, you can do 8-bit quantization, 16-bit as well. But then you have to see whether the output which you are getting matches your desired quality. The response time, of course, is better at lower quantization. So, of course, 4-bit will have the best response time. Here I have 3.8B model invoked with 4-bit quantization, and the response time, if you see, is very less. It's just 1.76 seconds. If I do 8-bit quantization, the response time is slightly more. So I'm getting the output in 6 seconds. Generally, in production environments, you would want a smaller response time, but then you have to see whether the output which you are getting specifies is up to your accuracy standards. Other than quantization, as Sandeep also alluded to, you can use techniques like distillation, pruning, and you can do inference on these optimized frameworks. So you can remove less important weights and neurons from the model to reduce its size and improve speed. You can use knowledge distillation to train a smaller model to replicate the behavior of a larger one. And as I just mentioned, you can use inference optimized frameworks so that inference is faster. You can employ, say, for example, when you are making calls to OpenAI, if you want to ensure that your output is returned faster than it is generally done, you can employ methods like top case sampling or nucleus sampling to reduce the computation required during decoding. Also, because when you leave the values to their default, a large number of value sets are considered by default by the model. If you specify your sampling rates in a specific manner, you can ensure that those sets are actually restricted. And of course, you can use RAG and fine tuning to control the output. So if you have a large number of documents which you want to process, you do not necessarily want to give the entire set of documents the context to the model. You can use RAG so that the right chunks are located through embeddings, and only those chunks are passed to your model for further processing. And if you still feel that the RAG is again becoming a constraint for some reason, you are having to use more tokens than you would want to, then, or maybe the model is still not giving you a personalized enough response, you could go for fine tuning the model. where you would have, depending on the use case, lesser number of token usage and a more personalized response, customized to your brand voice. So need not be the case always, but depends varies from situation to situation, depends on varies from one domain to another domain. You can cache and reuse your results, of course. You can implement caching mechanisms for frequently requested queries to avoid redundant computations so that inference is faster. You can use optimized libraries for better inference. So even if I use 8-bit quantization or 4-bit quantization, I can still use these libraries which act as wrappers to make the calls better. For example, I can use VLM library, which is a very famous library, to enhance the inference speed. As Sandeep initially alluded to, we can rely on model parallelism and pipeline and data parallelism. So the idea is to split the model across multiple GPUs or devices to handle larger models that cannot fit into the memory of a single device. In pipeline parallelism, we split the model into stages and distribute those stages across multiple devices. And each device processes its stage of the input sequentially, but does so concurrently across different inputs. And when it comes to data parallelism, the idea is to replicate the model across multiple devices, each handling a different subset of data. So in one case, we actually split the data across different devices. In another case, we split the stages of the pipeline. And then, of course, in the third scenario, the model is split. So depending on one's use case, one chooses the required strategy to improve inference. We can handle our input better. For example, we can avoid padding to the maximum sequence length. We can use dynamic padding because, of course, whatever input you provide, if you do padding in a constant fashion to the maximum length, it will create greater load on the model and you will have more response time, worse inference. We can use dynamic padding to ensure that that thing is minimized to the extent possible, at least from the padding perspective. And we can limit the sequence length. And generally, when people invoke large language models, there is a tendency to leave the sequence length as it is in the documentation at times. Or since people think that they anyway will be filtering out the desired response using some parsers, they need not focus on the sequence length. But then the point is, if you already have a large sequence length specified, the model will take slightly more time in generating that much, and then you will end up losing on the time. So of course, we have to ensure that we utilize our hardware efficiently. Now GPUs and other infrastructure and like TPUs are scarce resources. If we are, for example, running our models on an instance which has 4 GPUs, and if we are running a batch job, say we have a bunch of documents from which we want to extract information, and we have scheduled a pipeline, a batch pipeline to tackle this at 9 p.m. every night, we got to ensure that when that processing is happening, there is the efficient utilization of each and every GPU, because otherwise, even though it is a batch pipeline, you might not want to have delays beyond a point, and you more than delays in case of a batch pipeline, you would want to ensure that your outputs are correct. Nothing gets stuck because of GPUs not getting utilized, and more so in a real-time case, because of course if it is real-time and for some reason all GPUs are not being utilized efficiently, you have wrong responses on responses not even getting generated or delayed rather. So for example, when you have a batch inference use case, you ensure a good practice is to ensure that the different batches are queued in such a fashion that the requests are made to the GPUs, to the different GPUs, and an optimum utilization is ensured. Similarly, when it comes to real-time inference, you keep checking for the utilization of different GPUs on real time, and if any GPU is found to be utilized lesser, whichever GPU is least utilized or whichever GPUs are less utilized, a portion of requests is directed specifically to those. So these different strategies overall help in ensuring better inference for the same code. So of course, when we use libraries, we tweak the code a bit. When we use quantization, we tweak the models a bit. But that said, it's more about the infrastructure you use, how you use the infrastructure, and what kind of parallelism you adopt. Now, once a model has been decided, you have the right choice of prompts. You have maybe you are using RAG. You have put your model in production, or you have fine-tuned it. You have put it in production. You may still have issues going forward, because after all, it's not necessary that your data is static once and for all. Data will keep changing. Your model obviously is a language model. You can't ever expect it to have deterministic outputs. So you will always have to keep monitoring your models, and not just to ensure accuracy, but also to ensure that your model doesn't start reflecting the bias in your fine-tuning data, or in the new data which keeps coming in over which you try to fine-tune your model again. So the idea is to have a continuous monitoring pipeline for your model, whereby you can ensure that the model remains true to your expectations over a period of time as well. Now, when you implement a fine-tuning pipeline or a RAG pipeline, and generate some outputs which you load in your database, uh, it's important to ensure that those outputs remain as expected over a period of time. So there are different ways in which you can implement a continuous monitoring pipeline. Here I've shown one way in which that can be done using playbooks. So what you do in that case is you configure a set of queries that you generally would use for testing your data, and you need not put those queries, you need not go to your respective database server and run those queries, or maybe open putty and run those queries. And you may just configure them in playbooks. And then there are workflows where you can specify the respective playbook. And when this is done, what happens is, and you choose a Slack response or any other response, maybe you want to send information on Teams. Once these conditions are satisfied, now whatever, depending on the interval that you've specified, these playbooks are triggered, and these respective queries are executed. So the idea here is, once your model is in production, you continuously monitor your model. You do it regularly. You do it every day, every 2 days, or as per your time frame. And based on the checks which have been specified by you, reports are generated. Based on those reports, you can have another pipeline which is used to retrain the model or fine tune the model. I mean, it's the same thing actually, because models are generally pre-trained anyhow. So this is the third thing. Now, this is what I had with respect to enhancing reliability from accuracy, speed, and quality post-deployment perspective. Thank you.
Thank you so much, sir. Great presentation. Loved how you used playbooks for your presentation.
Welcome. So I have a
Let
bad throat. Sorry for that. I wasn't as smooth as I should have been, but there we are.
No, it was a great presentation. Let's take up some questions now.
Sure.
I think Rishank had a question
Yes, Rishabh.
in the question bar. He said, "Would love to understand how you're using GBNS grammar."
Yeah,
So I have actually, to be honest, when I used it, I referred to the documentation, I copy pasted it and had it in my output. But then I would like to mention that I appreciated that this is provided by default. This works by default for Llama CBP. So because when it comes to other models, I'm having to rely on other frameworks, as I mentioned here, and their documentation is though extensive, but then because it is extensive, one has to really spend time and look at the relevant information and customize your code accordingly. So, but yes, I did not go into the internals of the framework GBNF, but I ended up using it because I had the code available with me from the respective repository.